Welcome to Brain Vision.
In this problem, seeing our diagram, we have a ball of mass m, which is dropped vertically from rest from a height of h0 above the ground. It strikes the ground and then rebounds to a new height of h1 above the ground, and we wish to calculate the coefficient of restitution between the ball and the ground. So the first thing we will do is apply the conservation of energy, and we will use the ground as our datum. Now, the conservation of energy tells us that the kinetic energy at point A plus the gravitational potential energy at point A, TA plus VA, must equal to the energy, the mechanical energy at point B, TB plus VB. So point B is just before the ball collides with the ground. So a half m VA squared plus the gravitational potential energy Vg at A must equal to a half m VB squared plus the gravitational potential energy at point B. Now, initially the ball's at rest, so it has no kinetic energy, but it has gravitational potential energy mg h0. And this is all converted to kinetic energy at its lowest point, which is a half m VB 1 squared. The gravitational potential energy is 0. So subscript 1 denotes everything before the collision. Subsequently, the ball's return from position B to C will be considered again using the conservation of energy. So the conservation for the energy, kinetic energy at point B plus the gravitational potential energy at point B must equal to the sum of the kinetic and potential energies at point C. So that's a half m VB squared plus the gravitational potential energy Vg at point B must equal to a half m Vc squared plus the gravitational potential energy at point C. So this is a half m VB 2 squared plus at point B the gravitational potential energy is 0. This is equal to, at C we have no kinetic energy, but we have gravitational potential energy mg h1. So from here we can see that after the collision, VB2 is equal to the square root of 2g h1, and this velocity is upward. Now that we have this velocity, we can go and look at our definition for the coefficient of restitution, which we wish to calculate. Now, since the ground does not move, and we look at the vertical components and take the up direction as positive, we know that the coefficient of restitution is equal to minus VB2, the speed of the ball at B after the collision, over its speed before the collision, VB1. And so this is equal to minus the square root of 2g h1 over minus the square root of 2g h0. So if we simplify this, we get the coefficient of restitution to be the square root of h1 over h0.